So again, in this video, I'm going to tackle both questions 18 and 19 because they are so similar. And the directions here for question 18 are graph the linear equation. And we've been given the equation x equals 1. Well, what's unique about this equation as opposed to the equations that we looked at in 17 and 16 when we were graphing? Well, in question 18, we have an equation that has only one variable. In this case, it's just an x. We have x equals 1. And notice, were we given a table of values to graph, to solve for? No, we weren't, right? So if we quickly just look back at question 17, you can see again that we were Question 17. There it is. You see that we were given an equation that has both a y and an x, right? Two variables and an xy table that we had to first solve and then graph. But looking at question 18, we have an equation that has a single variable, in this case x, no xy table of values to solve for. So that's kind of a hint that, well, this one must not really have any work to do in order to graph. And in fact, it doesn't, right? If your equation has a single variable, if it has just x equals some number, or if it has y equals some number, graphing those two types of equations require absolutely no work. And before we graph this, let's quickly review. So if you have some equation, x equals some value, and let's call that value c, that's automatically going to be a vertical line that passes through, so passes through the x-axis at the value of c, so whatever c is. So in this case, we have x equals 1, x equals 1. So this is going to be a vertical line that goes up and down, and it passes through the x-axis at the value of c. So if the value of c is positive 1, it's going to be a vertical line that passes through the x-axis at c. But of course, we have to graph this on the computer itself. So what I will do is I'm going to get rid of just that line there. And just like before with questions 16 and 17, I'm going to click to enlarge the graph. And before I do that, I'll clear the screen so that doesn't get in our way. So here we have it, our graph, and we want to plot this line. We want to graph the equation x equals positive 1. So again, we know that this is going to be a vertical graph that passes through the x-axis at the value of the constant c. So to graph a vertical line, we don't have any points, right? But we know that every point on this vertical line is valid. So you have to click on two unique points in order to graph this particular vertical line. So what I would recommend you do is first and foremost, click on the point that intersects the actual axis itself. So in this case, this vertical line crosses the x-axis at 1, 0. So there we have our first point locked in. And now you can say, well, I can click anywhere so long as the point that I click on gives me a vertical line. So you might choose to click way up here at the point 1, 8, and that will give you a vertical line. And notice that it's locked in now. Or you might say, you know what, I don't want to click there. Maybe I want to click, I don't know, how about right here and way down here somewhere. Yeah, that'll work too. That's great. Notice that we have a vertical line that passes through the x-axis at positive 1. So if you want your line to look like that, that's also great. Or maybe you want your 2 points that you choose to lock in your vertical line to be really far apart, like that. Again, that's great. Not a big deal, as long as you have a vertical line that passes through the x-axis in this case, because it's x equals some number. As long as your vertical line passes through the x-axis at the constant, you're good to go. But because I like always choosing the point that intersects the axis, I'm going to let that be my first point, and how about somewhere up there be our second point. So we have a line that's locked in, so I'm going to save it, and you can see now that the 2 points that we chose disappeared. We just have a blue vertical line going through the x-axis at positive 1, which is exactly what we want. All right, let's go ahead and again advance to question 19 because this is very similar. We're told to graph the linear equation, and just like before, we've been given y equals -1. Well, again, because this equation only has one variable, it just has a y, there is no xy table of ordered pairs to solve for. This is kind of your little clue that, well, this question must not have really any work to do in order to graph. So, just like we did before, if you have an equation that is y equals some constant, some number, this is going to be a horizontal line that passes through the y-axis at the given value of c. Given value of c, the constant. So in this case we have y equals -1. So because it's an equation with just a single variable, in this case y, it's automatically a horizontal line that's going to cross through the y-axis at the given value. So in this case, -1. So this line, well, that's a pretty bad horizontal line. But anyway, you get the idea. This is a horizontal line that crosses through the y-axis at -1. If we were given, for example, y equals +5, well, again, it's an equation that has just a single variable, and because that variable is y, this is telling us this line crosses the y-axis. Where does it cross the y-axis? At +5. So let's find +5, which is right there, and again, we're going to have a horizontal line that passes through the 5 on the y-axis. But again, we need to actually plot this line using the computer. So let's clear everything, enlarge the graph, and it will load up at some point. Da, 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 da. All right, finally it loaded. There was some sort of server error, I don't know, but I edited that part out. So anyway, here we have the graphing window that's open, and we're still graphing y equals -1. So just like before, let's click on the line tool, and because we know that this line crosses the y-axis at -1, I'm going to go to the y-axis right at -1, and I'm going to click to lock that point in. And just like before, we can then drop the second point really anywhere we want, but of course we want a horizontal line. So I'm going to choose any point that makes a horizontal line. It does not matter which points you choose. Again, we can go back and really make our vertical line out of any 2 points. If you want to use those 2 points, that's great. What's important is that you have a horizontal line that passes through the y-axis at -1. So just like before, because I like the point to be where it crosses the axis, in this case the y-axis, I'm going to choose that point, and how about that point? All right, looks good to me. And when we save our graph, we're taken back to the test screen, and you can see the 2 points that we chose are now gone, and we just have a horizontal line that crosses, that intersects the y-axis at -1, which is exactly what this equation is asking for. All right, there is question number 19 and 18 in one video, and I will see you at question 20.